Hey everyone, this is developer Ashish, and today we are going to make a very simple regression project using linear regression and decision tree. Okay, this LR and DT basically means that. Okay, so we have today our very simple data set. Okay, and this tutorial is for absolute beginners. Okay, see, what we just need to do is we just need to train our model to generalize the pattern. Means what pattern means, see, if you are like in a company, okay, if someone is having years of experience 1.1, okay, 1 year and 1 month, then that person should get salary 39,343. It doesn't matter if it's in dollars, rupees or euros. Okay, just take it like this. And if someone is having experience of, let's say, 4 years, then it should get 55,794. If someone is having experience of, let's say, about 10 years, okay, 10.3, 10.5, then that person should get 12,118.72. Okay, sorry, 1,21,872. Now, don't get confused that this value is larger and years of experience smaller. It happens, okay, like it's a data set basically. So, what we need to do, we need to train our model in such a way that it can generalize the pattern like this. Okay, like this. First we will import data set and it will generalize the pattern that this years of experience is less, then that person should get less salary. Okay, and as the number of years gonna increasing, it is increasing, that person will get higher value. Okay, now what is regression project basically? Okay, before we go, move further and before we apply everything, I'm gonna write write whole code line by line. Okay, and I'm going to explain each and everything. But what is regression and what is classification? Okay, classification versus regression. Simple, very simple term is, see, which I'm going to explain basically like this. Okay, see here. What is classification? Classification is just classify between two or more things. Okay, like cats versus dogs. Okay, classification is that which is categorical, which doesn't changes with time. It doesn't changes. Cats will not become dog with time. Okay, cats will be cats, dog will be dogs. Okay, classification is this simple. And regression, what is regression? Regression is continuous variable. Okay, classification is categorical, regression is continuous variable, and it changes with respect to time, like salary, like a stock market, okay, like temperature, like age, our age also. Okay, it changes with respect to time. So this is a regression project because as the years of experience gonna increases, just like this. Okay, and see here. Okay, as the years of experience gonna increases, okay, the salary will be increased. Okay, see, even in our project it is like this. Okay, as the years of experience is increasing, the salary is increasing. But in the case of classification, by their years, cats will not become dogs. Okay, by their age and all. Okay, so what we are going to do is, that was just a basic introduction of regression classification. Okay, comment if you have any doubt. Okay, I'll solve it, and you can DM me on Instagram, link in the description. Okay, so then we are going to first import the data set, and there is no feature engineering, feature scaling, because this is a very absolute beginner project. Okay, and this, and then after that we will divide this into x and y, and then we gonna train and test split our model, and then we gonna apply the linear regression. Okay, we gonna apply the linear regression, and then we gonna predict, and then we gonna see the difference between the predicted value and the original data. See the difference. Okay, and in my case, and we gonna see which model perform better using these two metrics, you can say RMSE and R2. Okay, and descent regression. Okay, the second one, which we are going to then visualize how it's working and all. Okay, and we're gonna check its metric score and all. Okay, so if any doubt comes, you can ask me in the comments. Okay, so let's start the coding. So we're going to start from, like, of course, by importing libraries as NP. Okay, and soon I'm going to take the workshop for soon I'm going to take workshop. Do I need to tell you right now? No, wait, I was just planning for a workshop. So import numpy, import matplotlib, import pandas as PD. Okay, yes, there you go. And if anybody has not installed this, okay, then they will get an error called no module named pandas, or pandas is not defined, or whatever. Okay, so just do one thing here, put exclamation mark in the Jupyter notebook. Okay, and I suppose you are doing in the Jupyter notebook, pip install any of three of the libraries. Okay, let's say you want to install pandas, pip install pandas, shift plus enter, or directly run. Okay, whatever. So your installation of this library will get started. This exclamation mark is necessary to let Jupyter know that you want to install or you are giving a particular command. Okay, wait, just let me check. Yeah, recording is going. Okay, so pandas, I've already installed pandas, so it is saying that requirement already satisfied. Let's import the data set. Our data set, as I said, it is very basic. Okay, salary data, simple one, very basic, that see, salary is dependent variable. Okay, salary is dependent on the years of experience. It is independent. Okay, means okay, see, if you have a 1.1 years of experience, means you can say 1 year and 1 month. Okay, then your salary might be 39,343. It can be depend on your country, the currency, dollars, rupees, euros. Okay, but leave currency aside, but look at this. Okay, it is just a random data. Okay, it depends on your company, like what company you are working. But let's say okay, if you are working in a company called XYZ, okay, and according to their criteria, if you have 1.1 years of experience, okay, on that particular domain or the company, your salary might be this. Okay, 39,343. And if you have years of experience 2, your salary might be 43,525. If you have experience of 4, okay, 55,794. 8.7, if you have experience of 9, okay, 9 years, then your salary might be around, see, it is saying 1,05,582, then 10. Okay, this 1,21,872. Okay, so we have just very small data set, okay, of 39 rows. And what we are going to do, we are just going to fit our model, we are just going to train our model to generalize the patterns, to recognize the patterns, to understand the patterns, that when we give, like, let's say when we after the training, for testing purpose, if we say like Ashish Kushwaha is having experience of 6 years, okay, then our model should tell us that Ashish Kushwaha should get a salary around this, around 93,000 or 90,000 or 95,000, around this. Okay, and if I give my input after the training, okay, after we train our model, if I give my input, let's say Ashish Kushwaha, developer Ashish, is having experience of 3 years, then our model should say that whatever I have learned, according to that, Ashish Kushwaha should get 60,150 or around this salary. Okay, simple one. Okay, as I said, this is a very simple regression project. Okay, import this data set. Okay, data set, I'm just naming it data set. In many cases you might be seeing DF. Okay, that's whatever you want to name. Okay, some people name it DF as data frame. My salary data is in D Python 37. You can name it whatever you want. And here you go. Okay, not like this, sorry. First of all, of course, we need to write pd dot this pandas dot read CSV. Okay, if it is an Excel file, so you got to write read Excel. Okay, and D Python 37 salary underscore data, my name, my salary data file name dot CSV. Okay, and put R here, Python text everything in the forward slash. Okay, let me just check if recording going on or not. Sorry. So import this. Okay, now data set dot head. Okay, head function we use just to see some top 5, top 10 rows. Okay, so see 1.1 and salary, you can see if I give 10, here you go. Okay, you don't need to see all the 30, 31. Okay, so here you go. Now, as I said that it's a very simple project, so you don't need any standard scaler. Okay, as there is only one independent variable. You don't need to do one hot encoding, you don't need to do anything. We will do all this data feature engineering, data scaling, data selection, okay, feature selection, whatever we will do in the next project, COVID-19 data prediction project. Okay, and 2 more regression projects coming, okay, including that. But this is a very simple regression project just to make you understand. So just focus on regression. Okay, let's visualize the data. Okay, let's do one visualization. Let's visualize the data. PLT, this matplotlib we have done, no? So that we use for to make graphs and all. PLT dot, if you press tab, it will show many things, like see, okay, bar graph it will show. Okay, and there are many kind of graphs. Okay, so we just gonna use scatter plot. Scatter plot, in the x-axis we want years of experience, and in the y salary, in the y variable, in the y vertical column we need salary. Okay, so we can see how they are proportional to each other. Okay, from data set, okay, we need years of experience, okay, and from data set we want salary. Okay, and here you go. Okay, see, years of experience in the x. Okay, this is x and this is y. Okay, later on whatever we give, it is y. Okay, see, as the years of this is years of experience, this is salary. Okay, as the years of experience is increasing, okay, salary is also increasing. See, it is directly proportional. Okay, to those person who is having years of experience too, they will get salary of 40,000. Okay, mostly. So those who are having experience of 8, okay, they will get salary around 1 lakh. Okay, and 10 years of 1,20,000. So we will train our model in such a way that it will generalize this pattern. Of course, what is the pattern? They are directly proportional to each other. Okay, you can say salary is directly proportional to years of experience. Okay, so we will train our model to generalize this pattern, to recognize this pattern. So whenever we give that how much should salary we give the person who is having 10 years of experience and who wants to join our company. Okay, here it will show this output. Okay, you can make this more better. X label, you have function of under PLT X label. You can write here and years of experience. Okay, PLT dot YLLABEL salary, and you can hide this line. Okay, you can hide this line. It's like it is showing in the outside of Jupyter, something like that. Okay, here we go. Years of experience, salary. Okay, now let's move further and let's split this data into x and y. Okay, what is our x? What is our dependent variable? Years of experience. Sorry, what is our independent variable? Years of experience. What is our dependent? Salary. This salary is dependent On years of experience, right? We have only one independent variable. This is called very simple regression. Okay, simple linear regression, you can say. Okay, we will apply 2 to 3 algorithms, right? Here you go. Okay, so this is our x, this is our y. Y is our always target variable, dependent one. Okay, so let's split them and see. X is equals to okay, see, x, how we need to write is simple. Under dataset, of course we need from dataset, now dataset dot, okay, dot ilog function. What does ilog do is, it is, you know, it is to call according to the index. Okay, log function we can call according to the column names. Okay, you will understand, you just need a basic pandas, you can say, teaching. Okay, ilog, I understand this line. Okay, I'm explaining. We need full rows. Okay, you know this. Okay, here here in this side we write how much rows we need, and under this side we write how much columns we need. Okay, we have 2 columns, years of experience, salary, and we need full rows. Okay, we need full rows of what? We need full rows of years of experience -1. Okay, sorry, years of experience. Okay, we need years of experience up to salary, means we will not include salary, we just need the full rows of this. Okay, years of experience. Okay, if you know basics of pandas, you will understand. Okay, y is equals to data set dot ilog. Okay, here similarly we need full rows of what? Okay, of salary. So the last one, this. Okay, let's do this and see x, if you write x, see, you got this. Okay, you got just years of experience. Okay, and if you write y, salary column you get. Okay, but we need only values, not this index or this. Okay, we just need the values here. Okay, values, and similarly here also values. Okay, and there you go. See, now you get the values of years of experience, and similarly for y, there you go. Okay, the values of the salary. Okay, almost 31. Okay, okay, all right. Now let's move further and see, let's split the data into training and testing. Okay, next step is, okay, we get our x and y. Okay, we have now our x and y. Now let's split the data into training and testing. Means of course, see, we already have some small number of data set, right? But what we will do, we will split our data. Okay, we will, or basically here, okay, we will split some data. Okay, so let's say, or better I should make you understand. Okay, for very beginners, okay, we will split some of the data, let's say till here. Okay, or till here. Okay, for training, and we will test on rest of the data. Okay, so almost you can say 1/3 of the data we will use for 1/3, means okay, up to 20 we will use it for the training purpose. Okay, we will train our model, and 1/3 we will use for the testing purpose. Okay, to test our model if it is accurate or not. So okay, so we will split x and y both. Okay, means, you know, this 1.1 has the salary of 39,343. So we will divide them, you know, we will divide 20, about 20, and this one. Okay, don't get confused, just be with me. From sklearn dot model selection. Okay, we have okay, we need to import one more thing. Okay, we need to import one more thing. Import sklearn we don't need to. Okay, from sklearn dot model selection. Okay, model selection, we're gonna import train test split. Okay, if you press tab, oh, it is not. Okay, split. Okay, now what it will do, it will xtrain for the training purpose. Okay, for the training purpose, and xtest, okay, for the testing purpose. Or it's better if I write first ytrain. Okay, not mean, just to make you understand, ytrain the first 20 of x, okay, with its labels. Okay, with its labels. Okay, that's what I was talking. And xtest with, you know, the one third. Okay, last you can say from here 1/3 it will go for the testing. Okay, 1/3 of this x. Okay, and with its labels. Okay, then we can analyze while testing if it is accurate or not. Okay, y test is equals to train test split. We will apply train test split and x. Okay, x with y, with its labels y. Test size, what will be the test size? Okay, test size, it will be 1/3. Okay, 1/3. And do this, you know, to randomly you can say randomly split your data randomly. Okay, it's not like about 20. Okay, randomly 2/3 of the data will go for the training and 1/3 of the data will go for the testing. But so what will be that data? Random data. Okay, that means randomly just give it 101 so that your random data can you know, it can be matched with me. Okay, so you can give it any number, you can give it 0. Okay, every time it will randomly select. Okay, so just give 1 on 1. Okay, 101 so that your random data can look alike like me. Xtrain, see xtrain. Okay, xtrain and xtrain dot size. Okay, if I give I don't think it support size function. Yeah, 20. Okay, 20 it has it got. Okay, xtest you can see. Okay, for the testing I think I did something wrong here. Okay, xtest we got like a salary, I guess. Yeah, it should be like here right now, I guess. Yeah, xtest should be like here. And okay, now we got it. Thank God. Xtest, and if you look at its size, okay, size ID, and there you go, only 10. Okay, and similarly you can check it for y. Okay, y train. Okay, see, so this is the label of this which we will train. Okay, with xtrain and ytrain we will train our data to test. Okay, to test on the xtest, and we will match our result with ytest. Okay, so we'll train our data and we will test on xtest. Okay, and whatever we will get the result. Let's say we will test like 6.8 years of experience. How much should be the salary? If it comes closer to this ytest, okay, then our model is performing good. That's all. Okay, so let's go ahead. And first algorithm is our linear regression. Okay, here first algorithm should be, or let me mark it down here. Okay, oops, let me mark it. It should be linear regression. Oops. Okay, linear regression. Okay, the first algorithm.
So let's let's understand what is linear regression. Okay, linear regression. Okay, and in a simple way, and I highly suggest I highly suggest you to watch this video to understand linear regression in a very depthful way. You can say Eureka, you might be knowing about them. Okay, so this one, the 28-minute video, okay, watch this, you will understand linear regression in a much depth way, okay, much better way. But just let me just try to make you understand in a, like, you know, surface level, like the basic theory of why we use linear regression. See, you saw this, no? Sorry, you saw this, no? This, okay. In this, you can say salary is highly dependent on years of experience. Okay, the data points, you can see this is the data points. Okay, what we are going to do is we are going to train our model to train our, what we are going to do, we are going to train our machine learning model, okay, which is linear regression. And what does linear regression do is it draws a best fit line. Okay, best fit line to, you know, you can say it recognizes the pattern and it draws the best fit line. Okay, so that, you know, you can say after training like this, okay, like see this one is better, observed value. Okay, this is our actual data points. Okay, this is our actual data points in the blue line, just like this. Okay, and what we will draw another one, this line. Okay, one line which is our predicted value. Okay, so if our data points are very far than this red line, that means our model has not trained properly. Okay, means how far it is, this is called errors. Okay, means the less it is away, means the more closer it is from the line, the better. Okay, means this distance of the data point, the distance of the data point should be very minimum to this line. Okay, these are called errors. These are called errors. Okay, these are called errors, and it should be very less. Okay, so if they are very far, then our model has not fitted properly. Okay, and if they are very less, then our model is, you know, model is trained, model is generalized, model is fitted very accurately. Okay, just like this. Okay, if like see all the data points, and what is our best fit model, this. Okay, means it will train for multiple number of times. Okay, you know, iterations. Okay, that's why I'm saying to watch that Eureka video, so that you can understand in a much better way what is iteration, what is gradient descent. Okay, descent basically. So that's what linear regression does. Okay, it fits on the line. You can say, you know, if you ask like what's the relation between y and x, and it will just fit on this data point. Okay, fits on this data point to generalize them. Okay, and it will not fit here. The line will draw, the line will not get drawn here, here or here. Okay, it will get drawn on the center of these data points, means what we say, the best fit line. Okay, that's all. And yeah, let's check. And one more thing, like why it's not working, just give me 1 minute now. See this one. Okay, see, if your data is very scattered, right, very scattered now, if your data is very let me just try to see this one. Okay, or this is not best fit line. Okay, not the best fit regression line. Okay, this one, of course your line is going like this, your trend is like this. Okay, your data are like this, the line should be drawn like this, right? It should not be drawn like this. Okay, so that's not the, and this one, okay, nothing. So this is the best fit line. And how does it work? Okay, what's the formula? Y is equals to mx plus b. It works on the basis of that. Okay, so Yeah. So basically we use regression to to predict the continuous variables, continuous data and all. Okay, how do we call a linear regression from sklearn, that is machine learning library? Why I'm so mumbling and all. From sklearn, let me zoom in. Sklearn dot linear model. Okay, this is a linear model, no? And import from sklearn dot linear model, all the section of linear model we want. There are many kind of linear models, polynomial regression, and many kind of things you can search. Okay, linear, but in this we just gonna apply this one, linear regression, as a linear model. Okay, and how do we say, like, LR, let's give it name LR, linear regression. And how do we okay, first of all we are importing linear regression. Okay, how do we define it? LR linear regression, this one. Okay, just press tab and it will autocomplete. And why it's not auto completing, I don't know. Okay, linear regression. Okay, this. So we have defined our class and we have defined the variable LR. Okay, just this one. Okay, now okay, LR or LR dot fit. Okay, how do we train our model? Fit function, using fit function. Okay, this one. Now press shift plus tab in your Jupyter notebook. Okay, and you will see like this. You will see the parameters of linear regression. Okay, or here. Okay, you can even see here. Okay, like x and y you need to give, and the sample weight. Okay, but here these are the, if you know hyperparameter tuning, which I don't think, like, in linear regression there is not much not much parameters are there to play. Okay, but these are, if you know some hyperparameter tuning and all, you can define it. Okay, but in linear regression there are not much parameters you can see. Okay, well, let's move ahead. And linear regression dot fit, what we want to fit, what we want to train, X train. Okay, X train with its labels. Y train is the labels, right? Y train is the labels of X train. Okay, and that's all. And now if you press shift plus tab, your model is got trained. Okay, and let's try to call it, it will not show nothing. Okay, well, and yeah, you don't need to store this in a separate variable like this. Okay, so now your model has got trained on the training data with respect to its labels. Okay, let's predict on X test. Let's predict it on X test data, the testing data. Okay, how do we predict? Let's LR equals to, LR dot predict. Okay, if you just press tab, you will see fit function, get parameters and n jobs and many things. Okay, predict, we are calling X test, predict it on X test. Okay, and let's store this in prediction, or prediction of LR. Okay, prediction of LR. Many times you will see here ypred. Okay, many people write ypred. Okay, y prediction. Let's like y prediction and all, you can write anything. Okay, let's y predict LR is equals to LR or capital LR better. Okay, what we have named it already, dot predict. Okay, we have predict, and now see y predict LR. See what happens here. Okay, for the absolute beginner, we predicted on X test data. Okay, we predicted on X test data this data. Okay, and according to the test data, 6.8 Okay, those who are having experience of 6.8 should get the salary of this. That what is the labels of the test data? This. Okay, labels mean the salary, should get 91,738. okay, and this is our prediction on the X test. This is our actual data, the ground truth, what we are already having in this data set. Okay, 6.8 see 91738, this is in the test data. Okay, and now our model predicted, okay, 6.8, the person who is having experience of 6.8 years should get 91,477, and it is very close. This prediction data is very close to the actual data. Okay, see even this, those person who are having 8.7 years of experience is having, you can say, 1,09,431, very close. 1,09,893, very close. Okay, let's see the difference between the prediction and the actual value. Okay, let's see the difference. Difference of linear regression, you can name it anything, y test minus the actual one minus y pred LR. Okay, let's store and let's see them in the data frame. Okay, let me just write it. Okay, so give me a minute. Well, understand, pd dot concat, there is a function called concat. Okay, concat, and under the we just want to write it in a series. Okay, just write with me whatever I am writing and understand. In the you can say this section, in the right side we want y prediction LR. Okay, and in the left side we want series, we want the actual data. So it's like comparison of actual data and the prediction. Okay, the actual data and the prediction, and you can say our model has fitted very good, which we will visualize also. Okay, pd dot series, and one more thing we want to add, difference of LR. Okay, in the axis 1, x is equals to 1. Okay, where is the invalid syntax? Oh yeah, here it should be. Okay, you can even see here res df. See, it has given index number which we will just you can say correct it. Okay, but this is the prediction one. Okay, 91477, this is the prediction one, this is the actual data, and this is the difference. Okay, let's name them now, so that you can understand much better way. RSDF. Okay, result of data frame, I am giving name. Columns is equals to, let's name the first one prediction or the predicted data, whatever you want to name, the original data which we gave and which we are comparing, and that its difference. Okay, and now check. Okay, see, this is the prediction one, this is the original one, and this is the difference. There is not much difference, you can say. Okay, there are some like see, there are difference of like 2000 when the data is, when this one you can see, yeah, okay, it's like, you know, we can check the metrics. Okay, what the metrics is saying, see here, minus 8000 difference means the original data is 66 and the prediction is 75. Okay, it's like minus 8000. But in some cases, even though the data is like, you know, about 1 lakh and the prediction, and the difference is only minus 62. Okay, so let's, before checking the accuracy, let's visualize the you can say visualize the training and test result. Okay, let's visualize, and then we will check the metrics. Scatter plot we will going to use, x train, y train, and the color, which color? Red. Okay, red, we can easily see plt.plot, the plot that x train and lr dot predict the you can say predict and plot the line. Okay, color would be okay, line color would be I think blue. Okay, and the data points would be red or whatever you want. Okay, check, see, yeah, here let's interchange them, because above one you are having blue data points. Okay, so that you don't get confused. Okay, see, just like, see, that's like in the previous one. Okay, this is for the whole data, that's why data points is larger. Okay, and here we are just analyzing on the training data. Okay, that's why data points are less. And see, regression line, they are not much far. Okay, they are not much far. Okay, like see, most of the data are very nearer to this red line. Okay, so you can see that our data has predicted and fitted very accurately, you can say. Okay, you can even give the title and all. Okay, you know, plt.title, salary versus experience on training set and all. Okay, title salary versus experience on training set. Okay, we will this is for the training. Okay, means while training, okay, we have written a while training predict on X train data. Okay, while training how much it got correctly. Okay, we will visualize for this testing also. Okay, wait, just, and let me copy paste this one, X label, Y label also. Okay, there you go. Yeah, okay, let's do same thing for to visualize on the test one. Okay, let's do same thing to visualize on the test one. Okay, here just do one thing. Just write here, give me 1 minute. Yeah, just write it here, test. Okay, and y test and xtrain lr dot predict on the xtrain data. So now we are checking how much it fitted on the test data. Okay, while training it has fitted perfectly. Now as we saw this one, na, prediction. Okay, let's check, let's visualize this. Okay, pretty good enough. Okay, pretty good enough, you can say. Okay, they are very nearer, some are even fitted on the line. Okay, like this one, like this one, good enough. And now let's check the metrics. Now what is the metrics in you can say regression? Okay, whatever regression, doesn't matter whether it is linear, polynomial or anything. Okay, let's check the metrics. Let me mark around this and oops, from sklearn dot, oh sorry, not import metrics. Okay, or and yeah, there are basically now many kind of metrics in regression. Okay, I am going to explain, and we are going to use 2 regression metrics. Okay, regression metrics. Okay, you can 3 best metrics to evaluate regression model. Thought data science, very good, awesome. They are like you know, you can go through it. And what are regression metrics? And the best one which I have found is RMSE, that is root mean square error. Okay, there are like mean absolute error, mean squared error, root mean squared error. Okay, and R2. Okay, so we are going to use two metrics, root mean square error. Okay, you can read about it, and mean square error, which I'm going to explain. Okay, but we are going to use root mean square error. Numpy dot no, let me not write right now. Metrics dot. Okay, if you press tab, you will find mean squared error. Okay, mean absolute error you will find, mean squared error. Okay, but we are going to use root mean squared error. Okay, you can read about it, what are they. Okay, on the y, so we are going to compare the actual data with the predicted one. Okay, predicted LR. Okay, so if I press tab na, if I press tab, okay, this is for mean squared error. What we just need to do, okay, sorry, I ran it. What we just need to do, we just need to write here numpy dot sqrt. Here you go. That's all. Okay, and here you go. Now see RMSE. What is what's the RMSE? 4363. Blah blah blah, means you can say, like, you know, in this data, okay, in this data, and you know, most of the difference you can see minus 7,000, 8,000. So on an average, our prediction, okay, our prediction is you can say the difference between our prediction and y-test is about 4,363 plus minus 4,363. Means if you give as an input, okay, if you ask your model, hey, this person has worked 10 years, what should be his salary? Okay, and for 10 years we have salary, let's say like 10.3 now. Okay, 1,22,391. Okay, so our model, you know, will either say around and around, okay, around and around this value, okay, plus minus 4,363. So either it can be 1,18,000, okay, either it can be 1,26,000. Okay, so how to know if this value is good enough? See, our data is very the value of the data is very huge. Okay, if this is like, say, if this is 100, 200, 300, and our model and our RMSE value is this. Okay, suppose our this salary is, let's say, 100, 200, 300, 400, 500. Okay, and our RMSE says 4,363. So that is very bad. Okay, see, it depends on the context. Okay, means if our actual data is, you know, 100, 200, 500, and RMSE comes like, you know, 4,000, then it is very bad. Okay, but our data is in thousands, basically it is in 10,000s. Okay, tens thousand, 10,000s. Okay, it's more than, like, you know, around 40,000, 50,000, 1 lakh. So getting this value is good, is super good, and you can see our model has fitted properly. Okay, let's get you know, get R2. What is R2? You can read. Okay, let me just say R2. Let's just take R2. R2 is equals to metrics dot. So metrics dot R2. Okay, so from metrics we are calling R2 square. R2 score, sorry, not square, R2 score, and same thing. Okay, we wanna do this, so here we go. Okay, so let me run this again. Okay, and what's our R2 is saying? 97%. Okay, in our business domain, in the industry level, it is said that when R2 is greater than 70%, then your model is very good, you can deploy it. Okay, your model is good enough to deploy. If it is less than 70%, if the R2 score is less than 70%, then it is not good. Okay, so you can see here, okay, our model has fitted very good. So of course our R2 should be higher, and it is 97%. Our model has fitted very good. Okay, so that's why it is giving pretty much good results. Okay, so now let's give our model, let's test it more. Okay, let's do more kind of testing. Okay, let's test our model in, okay, let's give it custom. Okay, I'll predict, let's give it custom, you can say, what you say, custom input, okay, to predict. Okay, see how to give, again lr dot predict, instead of writing x test, okay, to test on all the 10 rows of test data, okay, instead of, we just gave our custom input in 2D array. Okay, let's say, okay, wait, let's say you want, like, you are asking your model, okay, this is your model now, which we have already trained. Okay, let's say you are asking this, hey, what should be the salary of the person who has, who has an experience of 6 years. Okay, then if you run it, you will get an error like, expected 2D array got scalar array instead. Okay, so you just need to do here. Okay, like this, and here we go 2D array 1 2. So it is saying that that person should get about 83,724. And let's compare it. Okay, let's compare it with our actual data. Okay, and what happened? Okay, and you can see it's like, here, okay, 93, it is saying 90 in the actual data. See, there are many kind of, around 6. Okay, there are 6.8, 91,738. In actual 6, it is 93,940. Okay, and in 5.1 years and 5.9 years, which is very near to 6, it is saying 81,363. Okay, and even in 7.98,000. So you can say our model is showing very good accuracy. Okay, like in 6 years our model is very nearer to this. Okay, 93. And see, because even see, it doesn't see, it doesn't mean that our model will see, a model will tell us this exact output. Okay, see this 5.9, which is very nearer to 6, it has a value of 81,363. Okay, 6.8 is having 91,738. Okay, so according to that, what model has generalized, what model has got the pattern, according to that it is saying that that person should get 83,000 of salary. Okay, let's say 1 year of experience, 35,000. And you can even see here, okay, you can even see here those person who are having about 1 year experience, 2 year experience. Okay, about that they are getting around same. Okay, 39,000, 46 and 37. Okay, same. 3 years of experience is getting about 60,000, around that. Okay, so you can see, let's say 54. Yeah, okay, even you can even check here. Okay, the 3 years old is having this, 2 years, same. So that's how you can give the custom input, and that's how you can do, basically that's how you can do linear regression. Okay, so our part of linear regression is completed. We have developed our model. Now you can deploy it, because your R2 score, your RMSE is very good enough. Okay, you can deploy it in the web. Move to our second regressor. Okay, second algorithm which we are going to apply, that is decision tree regressor. I'm going to write the code. Okay, don't worry, just letting you know that what we are going to do, we are just going to apply this decision tree model like this. Okay, it makes tree, which I'm going to explain you. Okay, don't worry. And on this basis, okay, on this tree basis, okay, it's gonna tell us the result, the output. Okay, if let me explain decision tree first. Okay, then we will write the code. Decision tree, what is decision tree? And according to this, it's gonna generate the output. Okay, and how does it works? Basically, it's used for classification as well as regression purpose. Okay, let me okay, see this one. Okay, what is the weather? Okay, this is like a tree, now this is like a tree, branches of the tree. Okay, that's why it is called decision tree. Okay, so see weather. Now, now if the weather is sunny, okay, if the weather is sunny, okay, then what is the time? See, there are basically three features. Okay, sun, sunny, cloudy, or rain. Okay, and you can say, like, if we want to decide we should walk or wait for the bus, okay, or we should go for the bus or we should go by walking. Okay, so that's how it makes the tree. Like if it is a sunny, then what time, how much time it's gonna take. Okay, or how much time you have. If you have less than 30 minutes, okay, then you should go with the bus. Okay, if you have less than 30 minutes, then you should go with the bus. Okay, or if you have more than 30 minutes, then go with walking. Okay, else is the you can say, is the weather cloudy. Okay, if the weather is cloudy and if you are hungry, okay, then yes, go by walking. No, then go with the bus. Okay, and if the weather is raining, okay, if it is raining outside, then go with the bus. Okay, so that's how it makes decision tree. Okay, that's how it makes decision tree, and that's how it takes its decision by making tree. Now how does it's gonna work in this regression project? Okay, it's like a classification now, walk and bus. Okay, decision tree in regression, let's see now. Okay, finally I got an example after applying decision tree regression for revenue prediction using temperature in this towersdatascience.com. Okay, so see, here they have just given example of decision tree, how if the salary is between, just one example. Okay, our project is little different. Okay, even though it is salary, but the values are different. Okay, but just an example. Okay, how does it works in regression? What is regression? The continuous variable. Okay, so if the salary is between 50,000 to 80,000, okay, if it is around this, no, then decline the offer. If it is yes, then is the office near to home? No, decline the offer. Yes, then provide a cab facility, accept the offer. No, decline the offer. So it basically works like that. Okay, let me even show you our example, okay, which I created. If the most least experience, okay, 1.1, but basically if it is less than or equal to 5.5, okay, and see the value 710, see this is the salary, okay, 71022.5. okay, if it is less than this, okay, or you can say if it is less than 5.5, so see, if it is 2.55, okay, then this, okay, then it should be the salary. Okay, if it is more than 5.5, then around 7.65, then this should be salary. Now there are more factors in between 5.5 and 7.65. In between what? Okay, is in between, if it is 5.5 years of experience, then salary should be this. Okay, else if it is having 9.75, okay, then even that C, okay, see, the salary should be like this. Okay, or like this, or it should be like this. Okay, see, till the last. Okay, till the last you can see. Okay, see, like this, like this. Okay, so see, it's always like in decision tree, it's always like if it is like this, then do this, or else do this. If it is like this, or else do this. Okay, that's how it works. Let's code. Let's start our coding. Let me just mark it down. Let's give some space. Mark it down, and decision decision tree regressor. Okay, here, there you go. And see, from sklearn, how do you call this? Okay, from sklearn, let me close this one, no need of them. From sklearn.tree, okay, decision tree we call from a file called tree. Okay, decision tree regressor, as I said, it is used for classification also. Classification means cats and dogs types. Okay, classify between two or more things. Regression is what? Continuous variable, like salary. Okay, salary always changes and all. Okay, so how you call it? dt dot, how you initialize it? This, just copy or whatever, this dt is equals to, here you go, class. Okay, now dt, now same thing, okay, you're going to write dt dot fit, just like here. Okay, just like here we did now, lr dot fit, after calling it lr dot fit in the x train and y train, in the training data with its labels, and then we're gonna test it on next data, test data, and then we're gonna compare it with the actual label. This was our predicted one now in the linear regression, and we're gonna compare this one with the actual one. Okay, see the difference, like the difference. Okay, we just gonna do same thing. Okay, there you go, x train and y train. Okay, and there you go, dt dot predict on x test data. Okay, and see, let's check our y test data. Okay, and let me store this in a variable y is equals to y pred, just like we used lr now. Here we're gonna use dt or capital or small, whatever. Okay. Here you go, and there you go. See, this is our prediction, this is our actual value on the test data. Okay, on the remaining those 10 now which we left for testing, this is our you can say the actual data. Okay, and this is our prediction on. Okay, see the difference. Now let's again check the difference. Okay, you can just simply copy paste this. Okay, and don't just change this to dt. Okay, and what is the difference? Actual data minus predicted on, and the code to display. Okay, you just need to change here. I again initialized it in dt. Oh, sorry, lr. Okay, no worries, I need to run this again. dt. Okay, and I think y prediction lr. Okay, again see. Okay, yeah, I think so. We done it. rsdf, or you should name it differently na, rsdt for this decision tree. Okay, rsdt. Okay, there you go. Yeah, there you go. See the difference. Okay, in our yeah, this is our original data. Okay, and this is on prediction one. Okay, so see, it is predicting, it is comparing the prediction of decision tree with the actual data. Okay, and here you go, difference. See the difference. Minus the first one, this one of the x test, which is having if we call x test, okay, which is having 6.8 years of experience. In the actual data, it is the salary should be, around 91,738, but our model says it is 98,273. Okay, it made the prediction. Here you can see minus 4,000 difference. Okay, here you can see minus 10,000 difference, and here you can see 519 difference. So just by looking, I can say that, you know, our linear regression, okay, made better. You can say our linear regression performed better. Okay, it predicted better. See, there is not much difference. Okay, there is only this minus 8,000, and then I think second highest this one minus 7, then this minus 59. Okay, minus 581. But in decision tree you can see minus 10,000, minus 12,000, minus 8,000. How did I miss it? So let's check the accuracy score. So what we learned here, okay, what we got to know here, okay, that every model, see, it doesn't mean linear regression gonna always perform better. Okay, every model performs differently with the you can say every model performs differently with different data set. Okay, here linear regression performed better. Okay, here linear regression performed better, but that doesn't mean in other data set, our decision tree not gonna perform better. It might perform even better than linear regression. Okay, then dt, and here small dt I had. R2 we are going to find there. Okay, we are going to compare in the root mean square error, y test, y prediction, y test, y. Okay, and with the R2 score. See, RMSE what we got. See, 7568. Okay, and in the RMSE of this we got this one around 4363. So linear regression, according to linear means how linear regression performed is, its result was on an average varied from the actual data about minus plus 4363. Okay, some on an average means sometimes linear regression saying that, you know, sometimes linear regression were showing minus 4000 difference or plus 4000 difference. Okay, but see, their difference is larger here in decision tree. Okay, so it doesn't perform better. The difference should be very smaller, no? It should be very close to actual data. Okay, but it is far. It is plus minus 7568. Okay, so even just by looking, as I said, just by looking we can see, okay, the difference were very huge, minus 10,000, minus 4,000, and even see here lots of minus data are there. Okay, not plus, but all right. And R2 92%, even though 92 is looking good, but as I said, linear regression perform better. Okay, 92 is looking good here, but it's not. R2 score is saying that it is 92% accurate or 92% closer, 90% RT score is. But even you can see that, you know, that doesn't mean you can use this model. Okay, now two things here. First, let's visualize by making these trees and all. Okay, but before that, let me just tell you one thing, that now you just need to do one thing. Okay, that you can apply here. See, data is very less and features are only one. Okay, there is only one independent variable. Okay, so you should perform linear model. Okay, mostly like support vector regression and all. So you can take this as a challenge and you can do text represent. Let's first represent it in a text form. Okay, which you are not going to understand. Tree dot export. What is tree? I think I have not imported tree. From sklearn import same from where we imported decision tree. Okay, tree dot export text, and what is this? DT, our model. Okay, capital DT. And now print, print, what we need to print? This text representation. See, which you are not going to understand, you know, like feature 0, which is having years of experience, 5 less than or equal to 5.10, then 2.55, okay, which we saw here, na, 5.5, then again 2.55, okay, then this you will go directly here, okay, 2.5 and all, okay, which you are not going to understand. So let's visualize this, okay, which even I am not able to understand much. Okay, so let's just visualize it, and you can even save this one also. Okay, but let's plt dot figure fix size is equals to 25. This is the figure size, okay, which you are going to write, and naming just a null variable, okay, or you can name anything, but not equals to figure. This is just a null variable, okay, nothing else. Okay, you can search about it. Tree dot plot tree. Okay, what we are going to plot? Decision tree feature. what, see, if you just press shift plus tab na, it should show suggestion, which it is not showing right now. Okay, it is not showing, but okay. Features name is equals to, what is our feature name? Under data set, what we have? Years of experience. Okay, years experience, basically it is experience. Okay, and there you go. And yeah, one more parameter you should give, field true. What is field true? Which I will show you. Okay, okay, I knew it's name fig tree. Oh, okay, that's why it was not showing initialization. Okay, now it is showing because I initialized it wrong. Filled true means, you know, the color is filling. Okay, it is showing the maximum probability and all kind of things. Okay, that's means you can read about it. You can read, you know, how to which I just previously, how to create a graph with decision tree. Okay, go this one, visualize a decision tree in 4 ways with scikit-learn. Okay, you have discovered data science also. Okay, which you will see. Okay, and you can even save this, like, you know, with open like this as, and you can save this text one, and you can save this one also. Okay, this field method is showing you know, the highest possibility and all. You can see, you can read about it. Okay, start reading documentation. Okay, see, please note that the color of leaf is the corresponding to the predicted value. Okay, start reading documentation, start reading how things are working and all. Okay, let's save this. You can even save this in a simple way. Okay, the last thing which we are going to write is save model, as we have initialized it figure na, plt.figure and all. So fig is equals to, so fig dot save figure. I'm going to save it in my this folder. Okay, which I have already saved. Let me delete it, and dpython37. Okay, and I'm going to name it dt only dot png. Okay, and put r here. Save fig, sorry, it is save fig. Okay, save fig. You can even press, when you press tab here, it will also show. Yeah, here you can see all the parameters, save fig. Okay, so see, dt, here you go. See, you have all this. Okay, and okay, everything is done, and if you want, you can even save this one also. Okay, I think they might you can even save this also. Okay, w with respect to w and all. Okay, you can even save this. So well, everything is completed. If you have any doubt, then ask me in the comments, DM in Instagram, subscribe, hit the bell icon, like this video, and comment any feedback. Okay, thank you everyone. See you with the next tutorial. Bye bye.